Hi, welcome back. This is our third video because we're reviewing for the test. So let's do it. We have question 24, says EH, so that's this distance. And they've asked us to find the midpoint and the length. So we're getting pretty good at this. The midpoint doesn't look like it falls exactly on the coordinate, but my guess would be -1 and maybe 1/2. Okay, so I'm definitely, if this comes up, I'm going to use the formula. E was -3, 2. H is 1, -1. So to find the midpoint, we add the two numbers, add the two x values, divide by 2. I get -1. Okay, and that was my hunch, -1. Now I'm going to do the same thing again, add the two y values, 2 plus a -1, and divide by 2, 1/2. Oh, cool. So guessing did work. Now I'm going to find this distance. Hopefully you're getting better at this. We see on the graph, I can draw this triangle. I got 3 boxes and 4 boxes. So I have, excuse me, shift it up there, 3 squared plus 4 squared, 9 plus 16, 25. But this distance isn't 25. It's the square root of 25, or 5. Okay. Now again, using approximation, we could have done this maybe another way and still got the same answer. So if I kind of use a scrap of paper, I noticed that there's the distance EH. It's just about that long. You could use a compass. If you line it up with the x-axis, see how it's 5. Make sense? Some folks, that doesn't make sense. Other folks, they're like, wow, I would do it that way every time because that makes sense to me. Now let's look at 25. It says, what are the coordinates of the point 2/5 of the way from H to E? So I wouldn't put it on a test. I'm usually starring the ones I wouldn't put on a test, but they're good questions, so let's talk about it. What are the coordinates of the point 2/5 of the way from H to E? Okay, so if I start at H, that's halfway. And 2/5 is something less than half. So 2/5 of the way, I would guess a coordinate right about here, maybe. In class, we thought about actually cutting it in 5 equal pieces. So if I cut this in 5 equal pieces, that's another way to see. 1, 2, 3, 4, 5. I've cut it in 5 equal pieces. This looks like 2/5 of the way there if I start at H and into E. So I'm going to guess this coordinate is -1 positive, -1/2 positive 1/2. That's my guess, and I'm going to leave it at that. -1/2 positive 1/2. I'm really hoping you're using your gut to try to answer these questions. Oops, what have I done? I put this coordinate in the wrong spot. Sorry about that. 1/2, 1/2. Now, H. Let's see what they're asking for H. Let's say Sadie models her neighborhood on a coordinate plane so that her school is at 812 and the store is at 14.3. So I've got some room here. Her school is at 812 and the store is at 14.3. Okay, so all these are positive values, so I only need a positive quadrant 1. 8, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so somewhere right here, 8, 12, and 14.3. So 8, 9, 10, 11, 12, 13, 14, 1, 2, 3, somewhere around here. Sadie models the neighborhood so that here's her school and here's the store. What is halfway? Okay, so it looks like halfway might be about, I don't know, 2, 4, 6, 8, 10, 12, maybe 12, 8? I'm not sure. If I had graph paper, I could definitely get my exact answer. So maybe this is a great idea to do the midpoint formula. So I'm just going to add my two x values, cut it in half. So I got 11. And add my two y values, 12 and 3, cut it in half. So 15. Half of 15 is a decimal. Okay, so that's maybe y. That'd be 7.5. So that's my coordinate. 11, 7.5. So let me see if I can graph that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Oh, okay, so I did graph it at 11. I was just too lazy to count. And then 7.5. 1, 2, 3, 4, 5, 6, 7.5. Beautiful. Pretty close. So if you had graph paper, I'm okay if you get close enough, but that would be the exact coordinate, 11, 7.5. Awesome. Last section, so let's get to it. Our last section talks about patterns. So hopefully you are pretty good at maybe drawing the next pattern or using words to describe it. And kind of a bonus would be if you can describe it using letters. This would be bonus if you can make the conjecture. And we have a couple kids that are really close to this learning goal. Some kids are already there. Some kids are still working on the picture, but that's kind of our learning goal here. So if you want to add in a picture here, that'd be great. Again, this is just a review, but I want to get to these questions. I want to have plenty of time to think about this. So I'm looking at the pattern, and again, I'm showing my work, but it looks like I added 1 and I added 4. And I added a bigger number. So maybe it's multiply. It's going up. So if you wrote going up, you'd be able to get some partial credit. If you said, I think it's add or multiply, you'd get partial credit. But maybe you're noticing if I multiplied 2, I didn't multiply 2 again. I multiplied 3. So if you're trying to figure out what got multiplied, you do the opposite. You divide. So 2 divided by 1 is 2. 2 divided by 1, 2. Now try the next one. 6 divided by 2. 6 divided by 2. 3. Keep going. 24 divided by 6. 4. Now I think I see the pattern that what's happening is I'm multiplying by 2, multiplying by 3, multiplying by 4. This one multiplied by 5. I can double check that. 24 times 5, 120. Beautiful. So I'm just going to multiply by 6. And then multiply by 7. Awesome. Let's do another one. I see here on 28, it looks like it's going up again. So maybe it's adding or multiplying. So it looks like I added 2, added 3, added 2, added 3. Oh, that's kind of a cool pattern. So I think I could keep going. So it looks like I'm adding 2, and then I'm adding 3, I'm adding 2, then I'm adding 3. So if I kept going on that, if I add 2, I get 15. If I add 3, I get 18. Awesome. Now let's look at the next one. It's going up, so again, maybe it's adding or multiplying. I went up by 3, up by 4, up by 5, up by 6. Definitely see a pattern. So they're adding 3, adding 4, adding 5, adding 6. So I want to add 7 and then add 8. Awesome. Last pattern, 17 to 1. Again, and if you can't see the pattern, you can just work backwards. So what is 21 minus 17? I get 4. What's 25 minus 21? I get 4. Okay, what's 29 minus 25? Still get 4. So it looks like each time they're adding 4. So plus 4, 33 plus 4, plus another 4. Awesome. Next question. It says, find a counterexample if you disprove, or if you approve, give me 4 examples. These are cool. Now these would be hard for me to grade, so I probably wouldn't stick them on a quiz, but they're still worth talking about. These 3 questions are really kind of good questions to talk about. Okay, so all triangles have congruent angles. Well, congruent means equal measurement. And I think I disagree with that. So if I disagree, I can give a counterexample. So there's a lot of examples to that, but all triangles do not have 3 congruent angles. If I think about an obtuse triangle, maybe these look equal, but that angle is way bigger. So a triangle in general can have different numbers. In fact, we call scalene triangles triangles that have 3 different angles and 3 different sides. So that would be an example where there's 1 big angle and 2 little ones. And that's still a triangle. Now it says if I approve or disapprove, but if I agree, I have to support it with 4 examples. So if I disapprove, I just have to give 1. This is called a counterexample. So let's see. If p is an even number, then p plus 12 is even. And I think I agree with that. I approve of that statement. So now I have to give 4 examples. So let's pick p is an even number. So whatever your favorite even number, maybe your favorite even number is 8. 8 plus 12 is 20, and yep, that's even. Pick another even number, maybe 10. 10 plus 12 is 22. Notice that's also even. I could keep picking them, so it says I have to give 4 examples. So how about 20? 20 plus 12 would give me 32. The number 32 is even. Last one, I'll just use the number 2. 2 is even, and 2 plus 12 is 14. 14 is even. All right, 33, construct an argument. So we actually saw this today. Explain why. Well, maybe we didn't. Explain why only 1 counterexample would be worthwhile to disprove it. Okay, well, I think this kind of illustrates that if this was false, this statement has. If you find 1 false, the whole thing's false. Just 1 true is not enough. Now, maybe explaining why is a harder question than you might think, and that's why it wouldn't show up on a test. But why would that be the case? Well, I can think of a couple examples where this wouldn't always be true. But let's go on to the next one. Okay, so this last one says, show how much he saves in his bank account and what would the rate be. So in our book, we did an example, and they did this divide by this to get this rate, and that worked out. So let's try that. So if I do 1.75 divide by 1, I get 1.75. 3.50 divide by 2, I get 1.75. 5.25 divide by 3, I get 1.75. So I see a pattern there. Now they're asking me, what would be the 10th week? So I don't know what that is. I'm going to call it X. But if I did have that number, I would take X, I would divide by 10, and I know I'd get the answer 1.75 because that's the pattern I've been getting. So hopefully you're thinking, if I multiply 10 on both sides using algebra, I'll have my answer. If I multiply by 10 on both sides, I will have my answer. So what goes in the box here? 10 times 1.75 is 17.50. Thanks for joining us.